Now we're going to actually practice our vocab to see if we understand where these come from. And you will have a section like this on the test. So don't forget to make sure you really understand it. In the diagram, it says the following. In the diagram, identify pairs of numbered angles that are related as follows. Complementary. Now we look and think, what's the definition of complementary angles? Two angles whose measures have the sum of 90. So I look for those, and I want to try to find the fastest ones possible. Well, I notice that this is a right angle, and I have two smaller ones that add up to it. Sum of the parts equal the whole. So the complementary angles would be angle 2 and angle 3. In fact, we could even say they were adjacent complementary angles. Then we had supplementary angles. Now we want supplementary angles are angles whose measures have a sum of 180. So I'm looking for angles, and remember it only be 2, so I can't use 1, 2, and 3 because that's 3. Supplementary angles are only 2. So I got to see what would make 180 degrees. So I start looking for lines actually. So like right here I got 3 and 4, or I could use 4 and 5 because linear pairs are going to give me two angles that add up to 180 degrees. So you could use either one. So I'm going to use angle 5 and angle 4, or you can say angle 3 and angle 4. Kind of cool. Then we just want to name a pair of angle 4, angle 1, and angle 5. All of those are adjacent. Now, non-adjacent means you don't want them touching. They can share a side or they can share a vertex, but not everything all in common. So a quick, easy example of that would be like angle 2 and angle 5. Notice they only have a common vertex. They don't have anything else in common between the two of them. And then we have vertical angles. Remember, vertical angles are formed by a pair of intersecting lines. So notice, here's your intersecting lines this time. This side and this line. And they form 4 pairs of angles, but I want 2 that are easy to name. Remember, they're the non-adjacent ones that are going to be formed. So notice 3 and 5 are my non-adjacent ones. So that'd be angle 3 and angle 5. Then we want a linear pair. Remember, a pair of angles from the same line. Linear pair. So I think I'm going to use 3 and 4 because here's my line. If I cover up the top part, notice the 2 angles being formed. 3 and 4. So angle 3 and angle 4. Now I want to share with you from our textbook things you can or can't assume from diagrams because we don't want to assume too much information when we're working in geometry. So in your textbook on page 97, right in the middle, they talk about what you can or can't assume. And I just want to zoom in so you can see this. Now, it says whether you draw a diagram or use a given diagram, you can make conclusions directly from the diagrams. You conclude the angles are adjacent angles, adjacent supplementary angles, hello, a linear pair, right? Or vertical angles. Those are things you can assume. You can also assume like lines are always straight, you know, but you can't assume parallel. You can't assume that they're going to intersect. You have to go with the information. But you cannot assume the following unless they're marked. Angles or segments are congruent, an angle is a right angle, and that lines are parallel or perpendicular. Remember, things do not have to be drawn to scale in geometry. So make sure you can find those. Now, let's keep going with our notes just a little bit more, and then we will stop for a second. And let's go through if we can use what we can decide using that last bit, what we can assume or can't assume from the diagram. Now, this is going to be critical now that you guys look for little signs. This is not very bright, so I'm going to turn on the lantern here. Forgive me. That you're going to be looking for things that are pretty obviously given, all right, unless they're marked. So look for arc marks, tick marks, and right angle symbols, because if they're in, then you can assume it. If they're not in, you can't assume it. It says use the given diagram and decide if you can conclude the following. Angle 3 is a right angle. So I look at angle 3, and it kind of looks like it's a right angle. It looks like it's a little bit bigger, but here's the thing. Is there a right angle symbol there? No. So can I assume it? No. Next one, angle 1 and angle 5 are adjacent angles. Now, if you look back on page 97, it says, yes, you can assume adjacent angles. So I double check. Do they have a common side, and do they share a common vertex? Yes. I can assume that. Angle 4 and angle 5 are a linear pair. Linear pairs are easy. Are they two angles formed from the same line? If I cover up the rest here, do I have a ray coming off the line, and do I have two adjacent angles? Yes. Are they forming a line? Yes. So they're linear. You can always assume that. Next one, can I assume vertical angles? Yes, as long as I fulfill the definition. Do I have two lines intersecting, which I do right here, and are they the non-adjacent angles? Yes. Therefore, they're going to be vertical angles. Now understand, 1 and 3 are not formed by the same line, so that's why they're not considered vertical. They have to be straight across from each other. Now, can I assume that angle 3 and angle 5 are congruent? Well, if I look at the diagram, do I have any arc marks? No arc marks, so therefore, nope, you can't assume. Now, let's look at angle 1 and angle 2. Oh, look, they have arc marks right here. Arc marks say they're congruent to each other. So, since they're marked in the diagram, can I assume they're congruent? Yes, because it is marked in the diagram. So if the diagram has it marked, then we can do a little more assuming. Awesome. Now we are going to quickly go through what a theorem is, and then we're going to start over and work on a few other important ones. A theorem, if you go back in time, you got to remember our very first day of major notes, we talked about point, line, plane, and space. And I talked about how Euclid was very good at defining a geometry. He talked about undefined terms. He then went to defined terms. And then he went to postulates, which are unprovable but true facts. But now we have theorems. Now remember, a theorem is a statement that is proven true by using previous definitions, postulates, and theorems. We are now going to start theorems in this class, where we are going to be able to prove them, and we can use them to prove other information.